Okay, so this is the iTECH Q Series CNC router, and what we're going to do is just show how easy it is to machine a piece of aluminium. We at Scott+Sargeant supply it complete with the Vectric software, and we're going to do a little bit of design on here, produce a small component, and then we're going to run it on the machine that we see here.
Yeah, that's good.
Okay. Alright, so let's go in. Okay, this is Vectric V-Carve Pro software, which we supply with the iTECH Q Series CNC machine. And I'm just going to show you how to design a quick component here. So the first thing we are faced with when we go in and set it up is whether we're going to be single-sided, double-sided. We set the workpiece up here. So we're going to be single-sided, we're just working on one piece of the unit, the workpiece, and we're going to set this at 280 millimeters by 280. And the workpiece is 6 mil thick, so that's fine. Go down here, OK that. And the other important thing is that we're going to be working from the material surface here. We can either work off the material surface or the machine bed. In other words, the bottom surface of the material. But in most cases, we always work off the material surface. So that's that position there, and we work off the front left-hand corner of the actual bed, so which is here. That's conventional. So here's our workpiece. We're going to do a simple plate here with a milled-out pocket in it. We can set some guidelines on here, which are always quite handy to have. Let's put a vertical in and put a horizontal in, like that, just to align things. We're going to put we're going to make a plate here, so we'll use the rectangle tool here. Just going back to this, we have all the vector making tools here, and we have all the editing tools down here. So I'm going to show you a simple plate that we're going to make. We're going to use, so we've got squares, circles, lines, text, we can do all sorts of things, polygons. But in this case, we're going to draw a rectangle, and it's going to be 93 millimeters wide by 34 high for this particular component. So that's it there. Close this. And when we click on it, we can reposition it by clicking twice, and we want to set it in the middle of this workpiece here. It doesn't have to be, it can be any way you like, but that's where we got it for now. Now we want to set in the middle of this object a hole that's 16 millimeters diameter. So choose the circle tool, where we can determine this by radius or diameter. We want something 16 diameter. So we're going to create that. It's created it over there. We don't want it there though, we want it in the middle. So let's just zoom in, and we can do this two ways actually. You can just click here and it'll do it, but since we've already created it, we'll do it this way. I'll just drag it onto the center of the plate that we're cutting out. And then we want, let's just zoom out a little bit. We want 2 4mm screw holes here as well. So let's put those in at the same time. So these are going to be 4mm. And we want one here. This is showing you the other way of working. On that. And one there. You can move these around as we did before. But that's all we need for now. Now we want to do a pocket. We want to mill out this section here because there's another meeting plate that's going to go in there. And that has to be milled out to a depth of 2 or 3 millimeters. So the way to do this is to use the pocketing tool, which we'll come on to when we set up the tool file. First thing we're going to do is draw a rectangle around this, and then we're going to show you another feature we've got in VCarve. So that's an area we're going to mill out. We don't want it exactly that shape, and we don't want it exactly there. So let's just move it central, and we're going to click on this and then go to node editing mode. So we're going to use one of the editing tools here. That puts a point on each corner, and we're just going to pull this over like that because we want this to be coming in at an angle, and same thing here. Now these angles you can determine geometrically, but I'm just doing it here for speed really of setting it out. You can also in here also do curves, so you can convert this into a curved object, curved dimension if you want. We don't want that in this particular case. So this is our component we're going to machine. Now to do this we have to do, we've finished the design now. That's the CAD side of it. We're going to make the tool paths now, work out how to machine it. The best way to do this is to machine these two holes first as a drilling operation, then do this pocket, then cut this circle out, and then finally cut all the way around it. So we're going to have 4 different operations. So first thing is to select this one. So let's just get onto the standard tool, standard cursor, that one and that one, and go to drilling. Drilling we've got set at 7mm depth, which is fine. It's going to cut through with a 4mm drill, that's fine. So we go through that and then calculate the path. It's a warning that we're going to cut through and close it. And we've done it. Here's our tool path, the drilling tool path. Next thing we're going to do is change the tool. We're going to pocket this out here. So let's select that. This is called a pocketing cut. We're going to use a 6mm bit here. So 6mm is that one there. And we're going to go to 3mm, halfway through the thickness of it. And we're going to raster, which means cut backwards and forwards until we get right through. And that's basically it. So we're going to calculate that. So that shows you the tool path, the way the tool is going to actually run to do that operation. So that's our pocket. Next thing we're going to do is select the circle because it's quite tight, and then we're going to just zoom in, select that, go to toolpaths again, and use the profile. This is a different one. We're going to do the profiling toolpath. We're going to cut around that. I didn't show you, but on the last one we were going around the inside of that pocket. On this one we're going to be going inside as well. So cutting to 6.5mm, we can stick with the same tool, 6mm tool, but we don't want to be going on the outside of the vector, we want to go on the inside of the vector, so that we're left with our 16mm hole. That. And that shows the tool path for doing that. Let's zoom out. So we've done the drilling, we've done the pocketing out of this, and we've gone right through on the 16mm hole. We now want to go round the outside of this and cut the whole thing out. So those are our 3 tool paths we got so far. So select that, go to the profile tool path again, with same tool in here. On this we don't want to be going on the inside, but we want to be going the outside of the vector, like so. And we can leave tabs here if we want, which you can define how big they are and where they are and the thickness of them. That just keeps it secure so that you're not cutting right through and ending up with a loose piece, which can obviously go through. We've got 2 screw holes, so we'll screw it down between the drilling and the profiling operations anyway, so we don't need tabs. So that shows that tool path there. So here's our 4 tool paths, which is going to we're going to copy that onto a disk. And before we do that, we can just view this in 3D and see what's going to happen here. And we can also model this so we can see see it actually working. So if we preview all toolpaths, that shows how the machine's going to work, and that's what we're going to be left with. And we can look at that in 3D if you like. So that's what we're going to be machining there. That's our component. You can zoom in on that. So this is the plate that we want here. So the other part of that's obviously going to come in here. So now it's time to save it. Close this preview down. So to save it, we have to save this as two files, one with the drilling and one with all the 6mm pocketing. If you try and do it all together, you get an error. So we'll save this. We'll save it into the machine, or we can save it to a memory disk. Normally copy it onto a memory disk. That's that. And then we want to do these 3 here. And do the same thing there. So these are the three pockets here. So let's call this pocket 2. So the first one was drill 1, so it's pocket 2. Save that. And now we're ready to go to the machine. So we'll go to the machine, we'll put this on. This is a water-cooled spindle on this machine. So it's a very high quality, very precise spindle. And the idea of the water cooling is that it's circulating water through here to keep the bearings cool, so even on long operations. First thing we're going to do is turn the machine on. Turn the controller on, turn the water up. The system is loading. First thing it's asking us here is whether we want to home the machine. Not normally necessary every time, but on this occasion we'll do it. The machine goes to its limits to find out where they are. That's called homing. This goes very slowly when it's doing the homing. Obviously it works much faster during the actual operation. So that's found its home position. The next thing we do is we set the 0 point for this operation. The 0 point is normally this front left-hand corner of the workpiece, but it can be anywhere. You set that during your design. So we're going to go X a little bit, Y, and then down. Okay, so that's just touching on the very corner of the workpiece there. So we've set X and Y to 0 and Z to 0. That is the 0 reference for this operation. So we go up now to just clear the workpiece a bit. We're going to run the program. So we press run pause. And it's asking whether we want to work off the UDISC file, this memory, the flash card, or an internal file, because we can copy these into the handheld controller if it's something we're going to be doing a lot of. In this case we're just going to be using the UDISC file, and it is called Demo 1, which is the drilling operation. So, oops, Demo 1, okay. So it's asking us the work speed, how fast it's going to traverse. This is millimeters per minute. We're just going to accept these for now. It's going to start, the machine's going to start, and this should just be a drilling operation. We can alter the spindle speed down here. We don't want too fast for drilling, so we can slow that down. So let's drill the holes that we wanted there. So next thing is, so we've got 2 holes here. That's all we were doing for the drilling. Next thing we're going to do is to do the actual milling. Screw holes, we've just put a screw in there. We can tab this so that the piece that you're going to cut out doesn't come loose. But in this case we want the screw holes anyway for this particular component, so it doesn't really matter, so we just screw through. So I'm going to change the tool now from the drill bit to the 6mm bit, and this will cut through aluminium quite nicely. So on this particular machine you can slow it right down so that you can cut aluminium. A lot of machines you can't get that slow, but on this one you can. And with a slow enough feed speed again you can also cut it quite nicely. If you cut it slow enough you don't actually need lubricant. If you want to go a little bit faster you need to give it a bit of a lubrication. So we're going to pop that in, and what we've done here is change the tool so the Z-axis height, the effective tip of the tool, has changed. So we've got to re-zero that. On the Q series CNC, they've thought about how to re-zero it, and you get this this little gadget here, this puck, which you can very quickly re-zero it. You just pop that under the tool, and you press on here Control and the menu and on/off. It'll come down, touch that, and then it'll automatically re-zero it, so you're ready to go again. So that's it. So we've re-zeroed that. Very simple indeed. Nice feature on this machine, makes the tool changing very easy. And we're ready to go. So we come back. So we're going to again choose the tool, the program that we want, which is called AA2. There we go. So here we've got the work speed. We're going to change this. We're going to slow this down so that we're not cutting so fast, because with aluminium this wants to be around about 200-300 millimeters a minute. You don't want to go too much faster than that. So by doing that, to do that, we press Run, Pause. I'm just going to edit this. So let's go to 50 and OK that. It's quite slow. We can always speed it up, but it's better to start too slow and speed up than try and do it the other way around. So that's top tip. So the machine's going to start, and we're going to change this spindle speed down here again to quite a slow speed. Around about 200 again. The machine's finished now, so we're just going to let's just switch off the dust extraction. So there's the component we've just machined. 2 holes, 16mm precise hole, pocketed out here. That's for another plate to come into. So that's all done on the Q series CNC machine. You can also do plastics on it, obviously any type of wood or laminate type material, even types of fiberglass material depending on the tooling you're using. But as you can see, it's easily able to do quite nicely finished components in aluminium. So we thoroughly recommend this machine for this particular type of operation. The heart of the machine is obviously this very solid framework that we put around it. Thank you for watching. So here's the component that we've made. You can rotate it, look at it. The component that was just machined on there is basically this. Put some